Welcome everyone to our presentation. My name is Martin Schulze, and together with Maria Borges and Alexander Walser, we want to present our thoughts about governance in a decentralized Gaia-X data ecosystem to you. Therefore, I'll introduce the topic from a general point of view, why a decentralized data ecosystem is suitable for our challenges in the product life cycle of autonomous driving functions. Afterwards, Maria will talk about the current architecture we build up for our specific Gaia-X research project, and this is followed by Alexander, who shows us how an appropriate governance framework could look like and which roles are needed. So let's start with some questions. Why are we even talking about decentralized data ecosystems? And which challenges for autonomous driving functions do we want to tackle? Basically, we see that the market of the automotive industry requires more and more virtual validation. In the past, only physical testing was used to ensure software readiness. But due to the growing proportion of software in modern cars, growing dependencies and complexity, that's not enough anymore. With product life cycles getting shorter and even stricter requirements for quality and certification, the validation by physical testing cannot handle the amount of required testing anymore, and it needs to be enhanced with virtual testing. You simply cannot drive millions of kilometers on real roads to ensure every driving scenario will be handled properly by every autonomous driving function. Of course, you can already notice the usage of simulation tools today, where the industry works on autonomous driving levels 2 and 3. But the usage of those simulation tools will be intensified in the future when trying to reach level 4 or 5 of driving automation. Through the previous presentations, we learned about some challenges of developing, producing, and operating sensors and ALKS systems. One of the main things is that the data of every involved partner is locked up in silos. If it is shared at all, it is done in inefficient bilateral trades. It is very complex to find suitable data sets of different data provider for a use case of a data consumer. Therefore, our project aims to create a data and service ecosystem that accompanies the entire life cycle of automated and connected driving functions. Within the data ecosystem, all participants can exchange standardized data efficiently and use services which are listed on a marketplace to accelerate their development, virtual validation, and approval cycles. Later on, we will show you how our architecture works in detail. But first, let's talk about decentralization. Why won't we use a central data ecosystem? Well, the main problem of a central ecosystem is that everyone got to trust the provider of that ecosystem because he got control over every participant's data. Our goal is to create an ecosystem where power and control is distributed between the user, so data is shared in a trusted environment. Therefore, we want it to be open for everyone, so nobody gets excluded. It will be a federated system that connects many provider and consumer of data and services in a transparent environment. The intention is to give control to the users by letting them decide which processes and common set of rules will be valid within the ecosystem. Everything while retaining sovereignty over their digital data. The mentioned common set of rules in a decentralized data ecosystem is necessary to provide the same competitive conditions for every participant, so that our data ecosystem is a secure and trustworthy environment where every participant exchanges their data or creates added value through it, and even got the possibility to develop new data-driven business models. The architectural structure of Gaia-X is based on the principle of decentralization. The Gaia-X the so-named Gaia-X standard is a result of many individual data owners and technology players, all adopting a common standard of rules and control mechanisms. To ensure interoperability between the variety of actors in a data ecosystem, the Gaia-X Federation services represent the minimum technical requirements and services needed to operate federated Gaia-X ecosystems. For example, you can see in that picture we've got components for identity and trust, which provide functionality to authenticate and authorize users. We've got the federated catalog, which contains every data and service offering. And for example, the compliance services who ensure conformity with data privacy, data security, and sovereignty. So now it's time for Maria to show us some insights into the architecture of our research project.
Now let's take a look at the architecture and the components that make up our Gaia-X ecosystem. I'm going to go through it step by step so as to not overwhelm you immediately with the whole architecture. So first we have a data provider who has assets to share in the ecosystem, and the consumer who doesn't have assets yet but wants to acquire them through the ecosystem. And to take part in our Gaia-X platform or ecosystem, these participants first need to be onboarded and sign up for the platform. This happens through a so-called trust anchor who issues them credentials that they can then store in their virtual wallet to use whenever they're interacting with the platform. Now that the participants have acquired their credentials, they can interact with the platform and exchange data through the following components. On the participant side, this means deploying the Eclipse Data Space connector with our PLC extension and interface. And in the backend, we have federators, which provide the minimum technical services needed to operate the ecosystem. In our case, we use a public blockchain and IPFS, and the federators can also operate nodes of these two components alongside it. Besides that, we also use the Gaia-X Federation services. For example, here we see the self-description creation wizard and the monitoring service, among others. And lastly, besides sharing data, there's also the possibility to provide services on top of the platform as a service provider. An example here on the top left is metadata search, which requires some technologies to work, like a graph database, etc. And here, a service provider could offer this functionality by deploying the required components themselves and interacting with the ecosystem through the federators in a similar manner to participants. So yeah, this is the first alternative for our architecture. We're currently also exploring other ways of governance for the ecosystem. Especially, we want something that would allow participants to use and interact with the platform, even if they don't have the technical means or the expertise to deploy these connector technologies themselves in their own infrastructure. So another model is to have service providers provide these components as a fully managed solution. We're currently exploring this as well. This gives data providers and consumers a simple to use interface for easy access to the ecosystem while still guaranteeing data sovereignty. So yeah, having just presented our architecture, here are some governance challenges that we face in the project. First, as you've just seen, we are using a public blockchain and IPFS. So it's of very high importance that we ensure the privacy and confidentiality of the participants. For this, we're currently implementing and investigating different privacy-enhancing mechanisms that can guarantee this. So guarantee the confidentiality of transactions even when operating on a public blockchain. And besides that, we also see the interoperability between different Gaia-X ecosystems as a challenge. We build on several Gaia-X standards like self-descriptions and the federated catalog to minimize this risk. Lastly, there is always a challenge of finding a suitable operating model and coming up with suitable workflows for this ecosystem. So next, we're going to talk about our governance framework as a way to address these last two challenges.
Hello everyone, my name is Alexander Walser from the Automotive Solution Center for Simulation. After the general overview by Martin and the insights into our architectural approaches by Maria, I would now like to talk about a concrete example of a governance model from our project community. The Gaia-X trust framework is the set of rules that define the minimum baseline to be part of the Gaia-X ecosystem. These rules provide a common governance and a basic level of interoperability across individual ecosystems while letting the users in full control of their choices. The trust framework foresees verifiable credentials and linked data representations as cornerstone of its future operations. Trusted information shall be retrieved in machine-readable manners, and if such manners are missing, Gaia-X will define processes to translate trusted information in a machine-readable format. This is a prerequisite of federating trusted statements within the Gaia-X ecosystem and developing mechanisms to reassess validity of claims within the trust framework. The trust framework can also be extended by domain-specific compliance rules. So a federation can add more requirements on the eligibility of the Gaia-X trust anchors, which lead to selecting a subset of the Gaia-X trust anchors for the federation's domain. And the federation can add additional rules on top of the Gaia-X compliance framework, adding more criteria for a self-description type. One example is adding requirements for a participant to join the federation, enforcing a deeper level of transparency for a service offering. This leads us to the role of the federator and the trust anchor, which we would like to explain with a concrete example. Although Gaia-X enables interoperability between individual ecosystems, very specific federations will emerge. These federations have common understanding of data and services, which will strengthen and accelerate the value creation of all participants. The federator has an important role to play here. It should combine and ensure the aforementioned principles of openness, transparency, democracy, and digital data sovereignty in a neutral governance model. So the question is, what could be a suitable operator model? Well, looking closely at the collection of requirements, one organizational form offers an outstanding intersection. A non-profit association inherently combines the necessary organizational structures and processes. Our Gaia-X for PLC AAD project already involves the Automotive Solution Center for Simulation, a non-profit association that has already developed and established governance processes outside of Gaia-X. The ASAS is an industry club bundling stakeholders in the field of virtual vehicle development. Our vision is, simulation is the key to future mobility. Simulation gives mobility a future. That's why we connect and bundle in our community stakeholders from the simulation sector to bring research into serious development by co-creation. In the invited research cluster, the ASAS bundles R&D activities as a collaborative environment for virtual test drive of automated driving functions. One example, which was already mentioned in the first presentation by Carlo and Marcel, is OpenMSL, the open source model and simulation library. It is a GitHub-based library for simulation models, tools, and processes developed in research projects or open source initiatives for industry-related applications. Here we developed a lightweight governance framework that ensures compliance and active contribution of stakeholders. We showcase best practices for model definition, data quality, and simulation credibility. This also includes the ASAM OpenX ecosystem, providing example implementations and discussion bases for standard interpretations. OpenMSL provides a valuable contribution to another activity in the invited research cluster. the invited data market. To build digital validation environments for sensors and ALKS functions, different simulation artifacts from different providers need to be combined. This data demand will increase strongly in the framework of virtual product validation. Therefore, the aim of the data marketplace is to satisfy this need by making the necessary data available, transparent, and traceable in the required quality and a secured way. Here we pursue the approach of converting the existing centralized invited data market into a distributed data space according to Gaia-X principles. This is a necessary but not a sufficient requirement for a simulation marketplace to scale. Another basic prerequisite is to find collaborative defined solutions to make data and its content findable, understandable, and comparable via common metadata descriptions. In addition, common quality metrics and certification processes must be defined to enable seamless data integration into the development environment on the part of the data consumers. This also results in new business models and services in the ecosystems, which we will learn more about in further presentations. In summary, this can only be done via a community or co-creation approach, whose governance regulates the compliance-oriented cooperation and seamlessly transfer its results into the data space architecture. In addition, the federator must ensure that a misuse of the service offerings and the discrimination of the data space participants is impossible to build a chain of trust. Therefore, the ASRS builds a compliance framework defined by the invited community, where the individual and layered compliance rules are applied on the invited ecosystem and the invited data space. At the root of the chain of trust are the trust anchors. A trust anchor verifies identities of ecosystem participants and issue credentials on the web in a way that is cryptographically secure, privacy respecting, and machine verifiable. So first we have to create a digital representation of ourselves. This is where an association like the ASRS can also play a special role, because the association is the central and neutral entity that all members trust. So an association as a federator and trust anchor could be the root of the chain of trust. Herefore we build a decentralized member identity management called DMIM. The traditional way of having an identity is to use your email and a password to create an account for the application you want to use. And normally you always use the same email and the same password. Once you get hacked, you lose everything. So now what was the solution to that? It was federated identities. You sign in with Google or you sign in with Microsoft. So now you trust a big company who knows about security, provide an API, and handle this well. But you centralize this identity to a specific company. And now the next step is to use a decentralized technology in order to ensure security and ownership of your identity. So DMIM is a web application to create verifiable credentials for companies to get accepted into the consortia and data space, and employees to get employee credentials from their company. So the trust anchor attests the attributes of your identity, which could be federation specific and defined in governance rules to be a trustworthy participant within the ecosystems and have access to specific services. For more technical details, I would like to refer to the SSI presentation from Felix and Hadi later. To sum up, in this presentation we demonstrated and highlighted the interplay between a Gaia-X based architecture and a governance framework using a concrete federator example from our project. We thank you for your attention and look forward to the Q&A session.